Straight lines are very simple things, but they do have a couple of properties which we just need to explore. The first one's the gradient of a straight line, and understanding this is particularly important if we're using equations of straight lines to model physical phenomena. For example, the gradient of a straight line can signify the velocity or the acceleration of a moving body. If I just draw an axis like that, it's our standard x, y Cartesian coordinate system, and let me just put a straight line on any straight line, something like that. Now this line slopes up from left to right, and because it slopes in that direction, we say that the gradient or the steepness is a positive gradient. Another line sloping up from left to right could be this line. This has a positive gradient as well, but the red line is steeper than the green line. Alternatively, we may have another line that slopes up from left to right, may look like that, still has positive gradient, but the blue line is shallower than the other two lines. Now lines that are parallel to the x-axis and aren't sloping upwards or downwards are said to have zero gradient. So each of these lines has zero gradient. They're flat, simple as that. And lines that slope downwards from left to right, unsurprisingly, are said to have a negative gradient. They go downhill, left to right. Now what I really would like to do is to find the gradient of the straight line that connects any 2 points. Let's just say A and B. And let's say A is the point x1, y1, and B is the point x2, y2, and we have a straight line joining the two. Well, we can see that this line has a positive gradient because it increases from left to right, but mathematically the gradient is simply the change in the y value divided by the change in the x value. So the change in the y value is y2 minus y1, and the change in the x value is x2 minus x1, and we can therefore define the gradient of this green line. So the gradient equals y2 minus y1 over x2 minus x1.